All right, notes 5.3 are on graphing inequalities in two variables. So we've learned how to deal with inequalities that have one variable. Now we have to talk about two variables. So if you remember, if I asked you to graph out x is greater than 3, what we would do is we would start right at 3. I'm doing just a quick sketch right now. And then we would put an open circle and we would shade everything in to the right of 3. Everything that we shade in shows all the numbers that work. So, for example, 5,000 works because it is in this shaded area right here. 3 doesn't work because it's an open circle. Now, if you also remember, when we have an equation, for example, that would say y equals 2x plus 5. If I were to graph that out, it would look like this. So let me just type it in so you can see what it looks like. So y equals 2x plus 5 looks like this. Everything on this line is a solution. So for example, the point -3, -1 right here is a solution to y equals 2x plus 5. So we indicate all possible solutions by graphing our line out. Now we're going to talk about what happens if you have inequalities, because not only can y equal 2x plus 5, but y, for example, could be greater than or equal to 2x plus 5. So that means that anything on this line would work, and anything above this line would also work. So how do we deal with that? First thing we need to do is graph the inequality as if you'd graph the line. So just like we did, I showed you right here with this 2x plus 5. But if it's less than or greater than when it's on the number line, if you guys remember, we said that it would be an open circle right here on 3, correct? But we can't put an open circle on an entire set of points. So what we do instead is we use a dotted line. Okay, so we'll say that it is a dotted or a dashed line. And then if it's less than or equal to or greater than or equal to, we'll use a solid line, because remember, solid lines mean that it works on that line. And then step 3, choose a point on the graph and plug it in to see if you should shade in that region. So let's go ahead and look at question number 1 together. Y is less than or equal to x plus 3. So the first thing I'm going to do is I'm going to graph it out like I would graph out any line I normally would graph out. So I'm going to start right at 3, because that's my y-intercept, and the slope is 1 over 1. So right here, I'm going to say the slope is 1 over 1. I'd go up 1 over 1, up 1 over 1, okay? And then use some type of a straight edge and connect your dots, okay? Now the question is, what kind of a line am I going to graph? Am I going to graph out a solid or a dotted line? Well, because it's equal to it, I'm going to graph out a solid line. So y is less than or equal to x plus 3. Now think about it logically. Since this right here is less than or equal to x plus 3, it should be underneath this graph that we have here. So let's go ahead and test any point that's under the graph. I generally like to test 0, 0 just to see if it works or not, and also 0, 0 is the easiest coordinate that you can plug in. So let's do our test. So if I were to test 0, 0, it would look like this. 0 is less than or equal to 0 plus 3. 0 is less than or equal to 3. That is a true statement. It works, so everything underneath will work. Now, I also am just going to do another quick check to make sure that other coordinates don't work. So like all of these coordinates above shouldn't work because it's less than or equal to 3. So I'll try -4, 4 and see what happens if I test -4, 4. So let's go ahead and do that. So it would be 4 is less than or equal to -4 plus 3. So I would get 4 is less than or equal to -1, which is not true. So that means that this side doesn't work, but everything underneath will work. So I'm going to shade in everything underneath right here. So let's go ahead and do that. This right here is my solution set. Everything below y is less than or equal to x plus 3, including everything on y equals x plus 3, is a solution to my inequality. Okay, and that was what step 3 said, to check your coordinate to see what happens. All right, so let's go ahead and try question number 2. Before I can do anything in question number 2, I have to make sure to isolate y, right? So in order to isolate y, I'm going to divide everything by 2. So when I divide everything by 2, I get y is greater than 5 over 2x minus 2. So then I would start at -2. And according to my slope, I would go up 5 and over 2. So up 5, 1, 2, 3, 4, 5, and over 2. Here's my coordinate right here. And then I would go down 5, 1, 2, 3, 4, 5, and over 2. So my other coordinate would be right here. Now the question is, can y be equal to 5 over 2x minus 2? It is not allowed. None of the numbers on the line will work. So I'm going to draw a dotted line to indicate that everything either above or below this line will work, but nothing on the line itself will work. Okay? Now I need to find out, should I shade above or should I shade below? Well, it says greater than, so it seems to make sense that shading above would work. So I'm going to check any coordinate that I want above it to see if it works or not. So I'm going to try 0, 0 again, just to see if it works. It happens to be that 0, 0, the origin, is in the area that we want it to be in. Again, it doesn't always work out that way. Now, when you do your test, you need to make sure you are testing in the original inequality. So I'm going to test it in 2y is greater than 5x minus 4. So I'm going to do 2 times 0 is greater than 5 times 0 minus 4. Okay? So 2 times 0 is 0. 5 times 0 is 0. So I get 0 is greater than negative 4, which is true. So that means that everything in this area will work. Now, to be honest, eventually I want you to get to a point where you don't have to do any checking, because I want you to graph these out quickly. So if you can recognize where you're supposed to shade, that's fine. But if you're getting them wrong, then I'm going to start asking you to start doing some checking, okay? Just be really careful, because a lot of people think you should go to the right or to the left, because that's what we were doing with single inequalities. But now we're talking about y, and y is your vertical value. So if it's greater than, you have to shade above. Sometimes shading above will be to the left, sometimes shading above will be to the right. What you're doing is you're looking at what's higher than the line, not lower than the line, okay? Now don't forget to label your inequality right on the graph. So y is greater than 5 over 2x minus 2, or you could write the original inequality. It's 100% up to you. All right, let's take a look at question number 3. We're going to solve question number 3 two different ways. So for the first option that I have is I can just get rid of the 4x. And the way I can get rid of the 4x is by subtracting it on both sides. So I'll subtract 4x from both sides, and I'll end up getting negative 3y is less than 9 minus 4x, right? Then all I'd have to do is divide both sides by negative 3, but be super careful when you do this, because what will end up happening is that your inequality sign will flip. So y will become greater than 9 divided by negative 3 is negative 3. And then negative 4 divided by negative 3 becomes positive 4/3. So y is greater than 4/3 x minus 3. Okay? That's one way to solve it, right? The other way is to force the y to be positive. So what I can do instead is I can add 3y to both sides. So if it's 4x minus 3y is less than 9, if I add 3y to both sides, I end up getting 4x is less than 9 plus 3y. Well, I want to get rid of the 9 now, so I would subtract 9 from both sides, so I'd get 4x minus 9 is less than 3y. Then I can just divide everything by 3, and I end up getting 4/3 x minus 3 is less than y, which is the exact same thing as what we have here in blue. If y is bigger than 4/3 x minus 3, then 4/3 x minus 3 is smaller than y. Okay? So now all I have to do is go ahead and graph this out. All right, so I would start right at negative 3, and then I would go up 4, 1, 2, 3, 4, and over 3. All right, and then go up 4 and over 3 again. So this is where you end up right here. And then I have a little bit more room to go down 4 and to the left 3, so I'll do that. So I'll go down 4 to the left 3. Here's my last dot. Now it's not equal to y. It's y is greater than this, so that means that I'm going to draw in a dotted line, okay? And y is greater than 4/3 x minus 3. Now it's greater than, so I assume I'm going to have to shade above this line right here. So everything above this line should work. But I'm going to do a test. So let's test 0, 0 and see what happens because 0, 0 is above the line. So test 0, 0. Let's make sure to test it in the original problem. So I'm going to do 4 times 0 minus 3 times 0 is less than 9. Well, 4 times 0 is 0. 3 times 0 is also 0. So I end up getting 0 is less than 9, which is true, which means that I can shade in everything above this line. Okay? So go ahead and shade in everything above. You've demonstrated all possible values of x that will work for your inequality. Excuse me, all possible values of x and y that will work because these are coordinates. All right, let's take a look at question number 4. In number 4, it says y is greater than 3. I don't have to do anything to isolate the y. So all I have to do is recognize what kind of a graph this is going to be. While y equals 3 is a horizontal line, so I'm going to start by graphing out a horizontal line. But y can't equal 3 because it's not greater than or equal to 3. It's just 3. So I'm going to draw a dotted line to indicate that it could be really close to 3, but it just doesn't touch 3. Now, if y is bigger than 3, it would make sense that I could shade in everything above here. But let's take a coordinate and plug it in to see if it works or not. So I'm going to try this coordinate right here, which is 4, 6. So I'm going to test 4, 6 and see what happens. So I'm going to plug in 6 for y. There's nothing to plug in for x, or there's no x for me to plug the 4 in for. So I get 6 is greater than 3, which is true. So I'm going to shade in everything above this line right here because it works. And it should make sense to you that all the y coordinates in this whole area right here are all bigger than 3. Okay? So now let's go ahead and take a look at number 5. X is less than or equal to -1. Now, there's no y to isolate in this one. This is our one special case that we have with all of our lines. It's our vertical line. So if x is less than or equal to -1, that means that I have to draw in a vertical line right at -1. So here is going to be my vertical line. So this right here is my x is greater than, or my x is equal to -1. Now, since it tells us that x is allowed to be equal to -1, I'm going to draw in a solid line, okay? And I'm going to figure out where I can shade it in. Well, if this time it's x, so I'm not looking at y, I'm not looking at vertical values, I'm looking at my horizontal values now. So anything less than -1 for x would have to be to the left of it. So I have to try some of these numbers right here. Again, 0, 0 is not in that area, so I'm not going to test 0, 0. Let's try something on in this section that we think might work. So let's try -5, 3. Okay. So let's test -5, 3 and see what happens. Well, -5 is less than or equal to -1 because this is the x value. It's true, so that means that everything to the left of this inequality will work. I can say x is less than or equal to -1, and then I am all set to go for that. All right, last question, page 8, number 6. What pairs of numbers satisfy the statement, the sum of two numbers is less than 10? Create an inequality with two variables to represent this situation and graph the solution set. Okay, so before we do anything, go ahead and number and label your axes. Come back to me when you're ready to go. All right, so if we don't know what the numbers are, we are going to have to call them some type of a variable. So what we're going to do is we're going to say let first number equal x, and then we can say let the second number equal y. So what I'm going to do is I'm going to add up my x and my y together, and it says that the sum of two numbers is less than 10, okay? So it's going to be is less than 10 right here. Now I can isolate the y, and in this problem it's easy to isolate the y, but what I'm going to do first is I'm actually just going to plug in some numbers and find my y-intercept and my x-intercept. Well, my y-intercept happens when x equals 0, okay? So that means I want to just figure out how do I graph out the line x plus y equals 10, all right? So that means that if x is 0, y is 10. So a coordinate that I know for sure it goes through is 0, 10. okay? And then to figure out my y-intercept, my x-intercept, that happens when y equals 0. The x-intercept happens here. Here is where y equals 0. So I would say x plus 0 equals 10, which means that x equals 10. So that means that another coordinate that it will go through is 10, 0. So I know 2 points on my line. I've got 0, 10, and then I also have 10, 0, and I know that it's not equal to it because it says it's less than 10. And then all the points that are less than 10 are all right here. So I'm going to shade in everything right here. Don't forget your arrows, where all of these values right here are all going to give me possibilities for two numbers that have a sum that is less than 10. All right?